scratching code, and today I'm going to write a Roman numeral converter. Basically Roman numerals. If you don't know what those are, that's IVXLCDM as the numerals instead of the standard decimal-based stuff that we use worldwide, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the idea is to get the Roman numeral into the decimal or decimal into the Roman numeral. We'll start with one direction to begin with and work from there. The basic rules of how this works is you got repetition. So like 1 is I, and then 2 is I, 3 is I. And then you got the subtraction-based numbers, which is a little tricky. So certain numbers, such as when you get to 4, it's IV. So I subtracted from V, which is 5, gives you 4. And then, of course, 5 would be V. So that's 1, 2, 3, 4, 5. And once you get to, it's 4, 9, 40, 90, 400, 900 that have the subtraction thing going on. Everything past that's basically an increment of some sort. And that's how you figure out your Roman numeral situation. Such as, let's see, VV is 10, IV is 4, VV is not 10. What am I talking about? X is 10. So XX would be 20 though, right? So you got that. XXX is 30. But then IX is 9, right? So that's one of those subtraction scenarios. And again, the subtraction scenarios are for 4, 9, 40, 90, 400, 900. Okay, with that, we're going to get rolling here into the code. All right. So I just opened up a folder like I've done previously. We're going to write this one in C# too. And start off with a test framework. I will call this Roman numeral tests. All right, and then for the code itself, I will create a class library for that, and we'll just test against the class library for the implementation. Roman numerals. Roman numeral, there we go. Yep, that works. Okay. So with that in place, I'm going to write some tests. Oops, unit tests. There we go. So for tests, I never like leaving the class just named that, but I'm going to go with that for now. And for this, we're going to turn this into test cases. So it's test case, and then I'll do the decimal number, which will be an int. So we'll do like 1, and then we want to convert it into I, right? And let's go down here, and I'll name this Roman convert tests int. Whoops, int. We'll just pass the value there, and then string is the expected string from the int. And then let's get another one of these in here. Test case 2, and that'll be 1, 2, and then we got 3, I, 3, and then let's go ahead and do 4. Test case 4, and that'll be, whoops, yeah, IV, and then about 5 into there. Right, okay. Now, this should fail if I write the actual test to pass here. Let's do assert that Roman, let's see, we'll call the class will be Roman convert, and then dot build Roman numeral, like that, and then we'll pass in the value, and it'll be value, whoops, and then dot is equal to the expected result. Okay, now with that in place, I should be able to now go and create this class, create type. Let's do a class, and then we'll implement the method. There we, whoa, didn't mean to do that. Let's see here. I want a string back, actually, not whatever that thought I wanted. Anyway, okay, so that's in place now, and this probably, yeah, let's make it static, because we'll just call it. We don't need to instantiate the object. And that looks good. So let's take this now and actually go put it in our class here. There we go. And now if we bounce back over here, we can say reference that class. What is it? Yeah, it said do that. Oh, weird. Okay, anyway, we got it in there now. And I can get rid of the in-unit thing because that doesn't need to be there. And we are set up here, so we can now implement here. But just to run the test and show the test running, let's see here, this is going to be Roman numeral test. Oh, so just like the namespace. And this is going to rename to that, to have that all in sync. All right. Now, if I run this, it'll fail because I haven't implemented anything, and we just get back blah, 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 like such. Okay. So now go back over here, and let's hear, this is Roman convert, so I'm going to rename this class, refactor it to rename Roman convert. All right. So we have this now. What is the best way to not throw an exception and instead actually execute and do some type of conversion here, right? Let's see. Well, the first one, we want to say equal to 0. Oops, shoot, 0. If it's equal to 0, we want to just return a string.empty. Okay, so that situation is handled. Oh, and actually, I should add a test for that. Let's not leave that empty. Let's do test case. So if we say 0, oops, string.empty. Oops, empty. Oh, is it string.empty? Oh, come on. Yeah, it's just this. Why is that not working over here? That's super weird. Let's just replace empty field with its value. Oh, so just do empty? Okay. And then let's see, let's see if we do test case null. Can I do that too? Oh no, because yeah, it won't take a null in it unless I make it nullable. But I don't want to do that. I just want to do it that way. So then we want to basically, okay. So again, let's think about this. The way Roman numerals work is like you have a number. Like let's say 1987. It's common. It's like people often do years with them just for whatever reason. First number, the first big number is 1,000. Okay. Second one, of course, 980, and then 7. So that's going to give you like an M, right? So M is 1,000. So take away 1,000 from 1987, you have 987 left, and it moves to the next big number. And that's 900. You take away that from 987, so then you have 87 left. And 900, by the way, is CM, so you have like M, CM at this point. And then you have, where did I get to? Okay. The next largest value is 87, so 50 L. And then you got 37 left over, so that'd be 30, 3 X's, and then 7, which is VII. So that's MCM L XXX VII. I think. It's always hard to do this shit in your head. All right, so that's how that processes. So we need to basically write that in the method, right? So I wrote we got rid of the 0 and the empty. That's taken care of. So let's see here. Our output is going to need to be a string. So let's get a string builder to put together the string, the MCM blah blah blah, like we were just talking about. So that'd be string builder. Result equals new string builder. Okay, and then I want to get those increment values, the particular sizings, and the weird off by 1 values, the negative values, right? Or the negation. I don't know what you would actually call those, but anyway, let's see here. You'll see what I'm doing as I put it out. So let's write out int values, and then wait a second. How do you? Yeah, well, and now it's shadowed out. That's weird. Anyway, so I need like 1,000, then 900, 500, 400, 100, 90, 50, 40, 10, 9, 8, 7, 6, 5, 4, and then 1. Okay, oops, 1. Now, I'm 1,000, not 100. Okay, so with these, why is this complaining? Oh, I'm calling too many things values. Yeah, there we go. Okay, I had a conflict there, but no more conflict. So the 1,000, 500, 100, 50, 10, 5, and 1 are all the values of the Roman numerals, and the 4, 9, 40, 90, 400, 900 are the negation values, where you have the previous Roman numeral subtracted from the next increment Roman numeral. All right, so now I want to get together our library of strings. It'll be our symbols, our Roman numeral symbols that we want to kind of map. They'll be mapped to this. So it'll be M, and then CM, then D, and then CD, right? Wait, C. Yeah, CD. Then C, we're on C now, right? Yep, and then 10 is the next one, so it'd be XC, then X, then we're at, we're at, I missed one, C, XC, then L, then XL, then X, IX, and then V, then IV, and then I. And I think that does it for us. Okay, so that basically gives me the mapping for those. And so when we start to write out the loop as we go through, and we go from 1,000 down, or whatever number we start with, if we only pass in 100 something, then obviously we're not starting at 1,000. But we'll go through each of the values, and we'll subtract that once we get to that value through a for loop. So something like this: for int I equals z. There we go. And then I is less than values dot the number of them in that array. Okay, and then semicolon I plus plus. So increment down through the or up through the values there, and as we get to each one of those, then we'll bump them off of basically the stack of the int that we've passed in as a value, and we'll assign the letter and then step through and continue onward that way. So should work. So then in here, while value is greater than or equal to the values that I'm at I, And you're gonna then append the thing, the Roman number symbol. Oh, wait, I want 0. I want wait, where I. Hit parens and then boom, semicolon, and then values negate from values the amount, which again will be I there. So then that should work. And then return result dot toStringy. And okay, so that should work. And now up here, what is this saying? What do we do arrays different nowadays? Use array initializer, remove redundant code in file, use collection expression. Okay, let's see what that looks like. Oh, it puts it in, goes from braces to brackets. Okay, syntax wizards, whatever. And then let's say you're using array initializer. What does that do? Oh, that just removes the new. So you don't need the new. Okay, I'm familiar with that. I'm not familiar with the other thing though. Use collection expression. I think so. Based on writer, this is the modern form of doing the array when you basically are assigning / instantiating it in place like that. Okay, cool, whatever. This one, let's see, I'm gonna use a var, and then here I'm doing that because I like to get rid of the lines. I'm not really a stickler for that. I mean, you know what type it's going to be. It's over there, but anyway, whatever. Okay, so that should work. Let's go back and run these tests. And hey, look at there. It's almost, I always feel like there should be a longer cycle time where you see like one pass, one pass, one pass, one pass. But the fact of the matter is, hey, it builds and runs super fast. So you get all the tests back almost instantaneously. And we have success across the board. Now, at this point, I'm gonna add another test or two just to kind of make sure, because I've only done a few right there. So if we go above 5, I might have messed up part of something. So let's get into the 500 range. Oops, test case. We'll do 500. And that will be D. Let's do 10. That'll be X. What's the other one? Oh, L. Test case. 50 is L, right? And then, oh yeah, let's go back here. Let's actually do one of the offsets. The test case 9, which will be then IX. Yep. Sounds good to me. Let's throw this test case in here for, let's just do a bigger one. Let's do like 2014. The year the Ruskies invaded Ukraine and Crimea. Bastards. All right, so then we got, let's see here. The two big ones, we got 2000, right? So 2000, whoops, MM. Dad, burn it, come on, MM. And then, so then we got 14 left, so that's XIV. So XIV, right? I think that's right. I'm going to run it and we'll see. Yep, that appears to be right. I like how it orders the tests. It puts them, that's weird. It doesn't run them in the order that you enter them in. So test case. Let's do, what's a good year? Let's do 1954. So we got M. Then 900 CM. 50 is L, and then 4. So IV. I think that's right too. Let's check it. Let's not debug. Whatever. Run the test. Okay, what happened? Oh, that was super weird. Why did that take so long? I don't know. Anyway, we got it. All right, with that done, how about we refactor? You know my MO if you've been watching the last couple. I like to refactor at this point. What I have, let's look back at that. So basically I step through these and assign the symbol and extract or subtract the number from the total number that I've been passed in as the value. And that gets me my string back. So let's say there's got to be like a cool way to clean up this code though. Using link and things like that, right? And just thinking, I kind of have an idea here. I'm going to nuke this. And we're going to go with my first idea here. So first off, let's actually not nuke that line. And then let's say if value is, I think, less than, greater than or equal to 1,000. Yeah, return m. Oops, and then build Roman numeral. So it's going to recursively call itself. Oops. 1,000. Okay, so that if I do that for each of the increments, including like the other ones, you know, let's say like that. So if, oops, minus 900. So if I go down each of those this way, that should actually get me the result. I think. Yep, that looks good. Logically that looks good. So if I go through each of these, so a little magic video here. I end up with this recursive function here. Oh, and then I gotta boom. Let's just can I just return oops, return, or no, I should have gotten through everything already. So that means I just need to do like a throw new argument out of range exception. There we go. And I'll just say something bad happened. So that should recursively nest into each call. I don't like this one though. Yeah, okay, I don't really like this. There's something about it that just seems dirty and recursive and weird to debug. I think I liked my other bit of code better, but let's go with this one for the moment. So it should run and it should pass. So let me see though. Okay, yeah, it passed all the tests. So, but I don't like this though, because it looks too blockish. It doesn't look like there's an actual flow to it. It just kind of looks like it bangs its way through the processing. Maybe it's even fast. I don't know. But anyway, it's one way to solve the problem through a recursive call. And like if we were ever to have additional Roman numeral digits, we could add them to this, but that's not happening because the empire no longer exists, even though people think about it every day. Haha, meme call out. And you know, there's not going to be new digits to it. There's not going to be new Roman numerals, period. End of story. So anyway, that's kind of what we're left with. However, thinking more, I have an idea where I could do it with link. as pairs, and then maybe like query over them, almost like a SQL-ish type of, or Lambda-ish query over it, linkish query over it. Let me see if that works. Let's give it a try. I'm going to nuke all this stuff again. I'm going to go with the same formatting, and here we go. Okay, so we still want to check and get rid of the 0 here. If I've made it value. Let's just do n for number. If n equals, number equals 0. Actually, I don't need to do this. I'm just doing one line. Return string.empty, like so. Okay, so that's done. And then return new dictionary. And we're going to pass in an int value and a string, because we're going to do basically a dictionary of all the Roman numeral values and their pairs. And then we need to do this. And then, okay, so based on all the pairs, then we'll do a where. The key property. Do that. Oh, it put so much in there. It's writing so many things. So p property of the number, right? I did, yeah, number, key value, and then select on that the property p dot value plus the, so to note, this is still doing it recursively like the other one, but I'm writing it out as a where clause instead of basically writing the literal dictionary and then making it happen for each dictionary entry. Even though I didn't really do a dictionary before, but anyway, it was being processed per entry as you go through and then calling back to itself, so it stepped through it. This is kind of basically doing the same thing functionally, but the code is way cleaner. If, of course, you're familiar with link lambdas and all of that jazz. Otherwise, this looks like cryptic nonsense, I'm sure. But anyway, so p value plus, yeah, and then call it recursively, and you're passing in the number minus the p dot key int string, right? I'm doing int string, yeah. So minus the key, which is the int, so minus that should, yeah, so if we're at 1,000 and we did like 1987 again, that'd be the 1,000 minus the 1,000, so now we're at 987 would be passing in for the first loop, and then we go for each respective loop, and then we'll do first or default. That'll give us the first value back every time, and it hates me for some reason. I don't know why, but we're going to find out here in a minute. Let's then put in some of the key value pairs, which would be, in this case, the first one is, of course, the 1,000, and that's m, and then 900, and that's cm. Having the outer braces and the inner thing be braces is, I don't, that's a troublesome syntax. So 500, and that is m, no, d, wait, c, m, t, yeah, yes, c is 100. Oh man, I just almost got that twisted in my brain. Okay, C, and then 500, and then we're at 400. You got to do that one, and that is CD. And I didn't put it in braces, so I just complained about it, which is exactly why I complained about it. Get that out of there. Okay, 400, and then you got 100, and that's C, and then you got 90, and that is C minus X. And then we got 50, which is L. There we go. And then the 40 XL. Down to 10. X. Almost there. Almost got them all. Oops. The next one is 9, which would be IX. And then we, oh yeah. Five. And then 4. That's 1. What is this fuss about? Change type method to string possible null. Let's just do that. Oh, that fixed all the stuff. Okay. Okay, so that should work. That should get us the test to pass again. Let's build it and see. And boom. Yeah, just let's do this. I just want to see something break for a second. Everything keeps working. Seems dangerous. Oh, CD. So we're going to do 400. Test case. 400. Which will be 400 is the CD. And let's do test case. Let's just increment it 1. 401. It should be CD I. That actually won't prove up my thing. But anyway, 400 will prove up my thing. If I do that again, so let me run that. So that passed. And then if I do something crazy again, like that. There we go. Yeah, CD and CDI, both of these broke now. Yeah, that's what I expected to see. That was good that I ran that. I need more tests now. So I should go back and add respectively the other ones. But anyway, with that, I'm going to actually call it. I've just refactored twice into this crazy dictionary thing. Let's see, can I do this to kind of put it? Yeah, okay. Let's put, I got this dictionary, but having it on one line like that just seems nuts. And then where, I wonder if I can do like, can I do this? Yeah, okay. So that, well, that looks really freaking weird too. Anyway, we'll put the functions out here like that. Okay. So that, I don't know if that, anyway, that's kind of where I'm leaving it. I'm going to leave it at that with my refactor that I just did. Anyway, the next video will be figuring it out with some random AI thing. I don't know what I'm going to use yet, but catch me on the next video and we'll figure it out. On this one, though, I've done 2 refactors. Both of the refactors ended up being recursive refactors, but this is based off of using a dictionary. The other one was stepping through like with if structures. And the original one was just kind of following the logic through more manually with more traditional C# type syntax, you know, curly braces type syntax. Either case, any of these things work. This one kind of seems like it might be the cleanest, but again, I always feel if I'm using the link lambdas and those bits that it's not clear unless, again, you are very familiar with those things being used in C# specifically. But it's definitely minimized code. It's pretty concise and pretty to the point. And you see your little box of dictionary items there that you're processing against. So that's kind of cool. Anyway, I like this one, so I'm going to commit this. It'll be available in the repo. And anyway, as I was saying, catch me on the next video and we'll refactor the whole kit and caboodle again with some AI tool. But you'll find out in that video. Cheers. Till next time.